Good morning, Keanu. Nice to have you here early in the morning. Well, okay, not so early. You guys might have already had another live stream. And it's Stephanie. Good morning, Stephanie. Got two already. Awesome. Let's turn so you can see the whiteboard. And there's Emelina. Good morning, Emelina. Very nice. Look at this. We're already flying. Good. I'll snuggle up in my 1 meter studio, or 1 square meter studio. And there's Frederica and Lisa. Hello. Nice to have you all here. I've got a Jonathan as well. That is great. And I've got Coco. Soupy, look at that. I'm almost a third of the way through already. Gosh almighty. Let's see. While we're warming up, let's just answer some questions. What is a molar mass? Molar masses can help change he to he or to. Good. Just something for you to think about while I write down my other lucky contestants. It's Remy and Tilly. Welcome to you both. There's Tilly. There's Remy. And I've got Yo and Mick as well. Good. Thanks for joining us, Mick and Yo. Now I'm up to half of you. That is cool. While I'm checking in a couple more people, let's see if you can answer these, all right? First off, what is a molar mass in your own words, okay? And then second, molar masses can help change hint to hint or to. See if you can fill in any of the blanks while I check in a couple more people. Because I need some more. There's 12. I need more of you to say hi. If you haven't said hi yet, please do so. I've got several of you. Should be here. My number's high enough. And I need to know who else is out there. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I got 12 up on the board. Let's see. There's another. It's David. Good morning, David. Okay, should we do the first one while we're waiting for people? Here we go. A molar mass. In your own words, can somebody tell me what it is? A molar mass. And I'll check in. Aaron is here as well. Thank you, Aaron. What's a molar mass? How about I start you off? It's the weight in of of one he or he. Let's see, there's David. I keep refreshing. Okay, the video page. I didn't notice it was on. I don't know what you mean. Are you okay now there, David? You should be okay. Okay. Hopefully you're okay. I don't understand your comments. Okay, Brooks is here. Good morning, Brooks. Do I have a UCN yet? Do I have Tully or Marino or Julius or Jordan? Do I have Emil or Matthew? So if any of you are here, please say hello. I still have a couple more that I should be checking in. Good morning. Hey, there's Julius. Good. Thank you, Julius. Okay, well, let's go ahead and begin. So this is review, right? So a molar mass is the weight in of one or Well, let's fill in the first. It's the weight in what? What is the weight in? What sort of label? Molar mass. It's in what? Type in. Hey, Marino está. Good. Thank you, Marino. Glad you're here. It's the weight in what? Thank you, Brooks and Emelina, in grams. That's correct. So it's the weight in grams of one. Actually, Lisa's even more correct. Grams per mole, right? Grams per mole. So it's per 1 mole. I'll just write it that way. Of one. Oh, I kind of ran out of room, didn't I? My blanks don't make a lot of sense here. I'll change it to this. So it's the weight in grams per mole, actually, of 1 mole of one. That's supposed to be a 1, not a 2. Of 1 mole of He or He. So it could be a mole of what or what? Thank you. A lot of you got mole. Good job. So it's 1 mole of or So it's a mole of what? Remember, it's a really big number of or Can you fill in either the last little blanks? I know it's a little hard to read. I'll read it again. The weight in grams of 1 mole of or Atoms is correct for 1. Thank you, Marino. Atoms, or what else could it be? Somebody else. Atoms are elements. Close. Atoms, or another word too, Emelina. Atoms are the things that make up elements. Atoms, we got atoms, yes. And Brooks, molecules. So it could be atoms or molecules, right? Like atoms, for example, Cu, copper. Molecules could be H2O, right? Like water. So it's more than one type of atom in there. A mole's worth of either of those would be a molar mass measured in grams. And a lot of you have that now. Thank you, Stefan and Lisa, Emelina, and Aaron. Appreciate you participating. We're getting warmed up. Here we go. The molar mass can change to H or to H. Okay, who can fill in either set of blanks? I'll get the green marker out for our next lucky contestant. So molar mass can help change to or to And yes, I know there's a lag time until I see you. Jonathan is there. Good. Let's see if some others are there as well. Again, sometimes you're typing and I don't see it for a few seconds later. Yes, good. Lisa and Tilly is there. Good. Oh, it's having technical difficulties. UCN. Thank you. Thank you. There. Tilly. Okay, so yeah, good. Several of you got it. Brooks, Stephanie have it as well. So it's grams to moles. Or if we flip it upside down, moles to grams. Good. We're going to start using moles next week. Today we need to talk about balancing reactions a little more and why we do it. So I think I'm going to go ahead and begin. So UCN we don't know about. Is Tully there yet? Or Jordan, Emil, or Matthew? Still missing those 4 people. I'll put that over here and I'll get our periodic table because I need that next. I'll set that there. You don't mind that if I sit on the keyboard? No, you don't mind. Okay. Can you read the whole thing again? Yes, I will, Lisa. Okay, here we go. I know my writing's sloppy. What is a molar mass? Well, it's the weight in grams of 1 mole of one. Well, that's sort of stupid, isn't it? 1 mole of 1 mole. I don't need two 1 moles, do I? No wonder you can't read it. It's terrible writing. Let's try it again. So, molar mass is the weight in grams of 1 mole of atoms or molecules. Ah, Tully's here. Good. And the other thing I wrote, molar mass can help change grams to moles or moles to grams. Thanks for checking in, Tully. Hopefully UCN can join us as well. I know she's having technical difficulties. Okay, we ready? Okay, here we go. We're going to start today with butane. And we're going to review balancing a reaction, and then we're going to talk about why we do that. You're welcome. Butane. Folks, where do you find butane? Who's heard of butane before? Where do you find it? Where would I find butane? You can buy it. Who's heard of butane? It can fuel stoves. Yes, it can. Yes, Brooks. And even more commonly, you can buy it in a grocery store or wherever, or a Tobakladen. Where else can you find it? Anybody else? He's right. It could fuel a stove, like a backpacker stove. It's in cigarette lighters. In cigarette lighters. In German, the word is Butan, so only without the e at the end. It's the same word. Well, if you didn't know that, you learned something new. That's all right. So, Butan. So in a cigarette lighter, so Feuerzeug, right? Here's the formula: C4H10. You'll learn more about it next year, but let's just go ahead and do that. Let's say we got a cigarette lighter burning. So it's a liquid, if you've seen it, right? It's a liquid in the little cigarette lighter. We said a lot of things burn with what? What's the gas in the air that reacts with a lot of stuff? What's the air is made of several gases, right? What's the one gas in the air that's very reactive, that reacts with a lot of other stuff? In other words, probably the butane reacts with what? That's butane. What do you suppose it reacts with in the air? Stephanie knows oxygen, right? So that's oxygen O2, right? Because it's a Brinkelhoff. And when it's in the air, they travel around in little pairs. That's a gas. Forms, kind of like we did last week. Several of you knew that. Aaron knew that. Julius knew that. And Tilly knew that. Good. Thank you. Yo as well. Good. 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 It's Bhutan in German. Exactly. Yeah. When I burn lighter fluid, do you have an idea what is made? Hint, it's the same stuff we made last week when we burned propane. So if you have your notes handy, you can look back and give me the answer right away. What did we get when we burned propane? Because it's the same two things that form when I burned butane. So I burn this, I get the same products, we say, right? These are the reactants. And the other side are the products. We knew that, right? I hope. And in the middle, we say forms or yields or makes. Makes, forms, yields. I wish I could see you because then I could hear you too. So when I hear you again, I can see what we're making. Good. Stephanie's looked it up. Thank you, Stephanie. Water and CO2. So did Lisa. So water, H2O, and CO2, CO2, carbon dioxide. Those are both gases in this reaction. I'll put a G and a G. Now, we're going to balance this thing. And remember my balancing rules from last time? Brooks had it as well, as did Marino. My balancing rules were pretty much just balance one element at a time, but do the Brinkelhoffs last. Okay, O is a Brinkelhoff. We're going to do O last. Okay, you ready? So now check this out. C4, ignore everything else. 4 C's. CO2, 1 C. That 2 counts for the O, not for the C. So this is not balanced. What could I put in front of CO2 to balance this? C4, just 1 C. Who remembers how this works? What do I put in front of CO2 to balance this sucker? You can look back in your notes from last time too to see how we did this. What would go in front of CO2? Good. Brooks knows. Let's see if some others pop up with their response as well. Emil, good morning. And some other correct responses too. Thank you, Brooks. Thank you, Marino, Lisa, Yo, Stephanie, Aaron, Emelina, and Tilly. All correct. So let's put a 4 there. The C's are now balanced. 4 C's. Remember, it's like a multiplier. 4 times 1 is 4. And then 4 is in the formula here anyway. Okay, ready for this? H10, H2 in H2O. H10, H2. What can I put in front of the water to balance the H's? What can I put in front of water to balance the H's? They are not balanced right now. 10, 2. Remember, we're ignoring the O's until the end. What can I do to balance just the H's? What could I put in front of water? It's like a multiplier. Hey, a couple of you have it. Brooks, Marino, Yo, Lisa, Julius, Emelina, Emil has it. Good. A 5. Let's just check that. So 5 times 2 is 10. 10 here, so 10 and 10. Correct. Good. Last step, we're going to do the O's. Here's why I do the O's last. Because they're in 2 different places. That's complicated. Let's find out now how many O's we got. I'm going to erase this for a sec. So I have a little room to write. The 5 in front goes all the way through the chemicals. So it's like a multiplier here, 10 H's, but then there's only 1 O, so 5. So I got 5 O's out of here, out of the water. Let's go to the CO2. I got 4 C's, but for the O's, it's CO2. So it looks like I got actually how many O's coming out of the CO2? Let's see if you're following. How many O's do I get out of just the CO2? Oh, do you know? I got 5 O's out of the water. How many O's out of the CO2? Thank you. Several of you knew. That's great. Stephanie knew. Yo, and Brooks. So I got 8. It's like a multiplier. So I got 8 O's. So altogether, I got 8 plus I got 13 O's, don't I? Okay. So here's what we do. We come back and we say O2. Well, what if I put 13 there? If you think about it, now I got to multiply, right? 13 times 2, that's 26. That's too much. That's too much. That's twice as much as I need. So what we're going to do is we're going to say, oh, it's 13 halves. Ooh, can you use fractions? Only in front of Brinkelhoffs. So I'm going to put a little star there. Fractions allowed only in front of Brinkelhoffs. Brinkelhoffs. So only in front of Br2 or I2 or N2 or Cl2 or H2 or O2 or F2. Woo! Now, here's a cultural difference. You ready? Whoops, you're losing my screen because I made it too high. Boop. A cultural difference. My German colleagues don't like fractions. The rest of the world doesn't have a problem with it. But if you have chemistry in German next year, Germans, Achtung, no fractions. So what you do is, you ready for this? It's like something in math class. Double everything. I'm going to show you how to do that in a second. I'm going to write it right up above, and I'm going to double everything. And if I double everything, you ever have a recipe in the kitchen and you double it? It still works, right? So just like a recipe, I can double this reaction. Okay, ready? Stand by. I'm going to now do 2 butanes, 2C4H10 liquid plus. Okay, I'm going to double 13 halves. You ready? That would just be 13. So I got 13 O2s. That's a gas. Forms. I'm going to double 5, so it's 10. 10 H2O gas. Plus, and I'm going to double the 4. 8 CO2 gas. Now, again, most international books, you'll see lots of fractions. I don't care if you do it the fraction way, or if you don't like fractions, you can multiply by 2 and get rid of all the fractions. Either way is okay. All right? Either way is okay. Emil asks, what is a Brinkelhoff? Okay, here we go. A Brinkelhoff, Emil, it was an easy way to remember all of those that come in twos. Remember, like O2 that's in air, it comes in little packages of 2. If it's an element, so not combined with somebody else, all these little packages come in 2. In other words, if I had just Br2, it would be in a container, and they would come in 2s. I's come in 2, so I2, N2, Cl2, H2, O2, F2. All of those amyl come in 2s. So when I say Brinkelhoff, it's just a funny way to say all of these elements that come in 2s if they're alone. I hope that helped. Okay. Now, I did this for two reasons today, folks. One is I want to talk to you more about balancing, and we've balanced now another reaction. The second is I want to do something. Good. Okay, good, Emil. The second is I want to now do something with this reaction. I'll take the top one, okay? The one without fractions. We're going to do something, and you're going to think it's really weird, but we're going to do it, and you're going to see why I'm doing it, I promise. It's going to lead us to something important. Ready? So we're going to find the mass of each side. The mass in grams of each side. How do we do that? It's not so hard. It's not so hard. Exactly, Stephanie. You're going to help me by using your periodic table. So find your periodic table, please, because you'll need that today. Find your periodic table or call one up on the internet. You really have to have one because you're going to have to look up some molar masses for me. By each side, I mean this. Let's do the reactant side first. We need to get the molar mass of C4H10. In other words, butane. Remember how we do that? What's the molar mass of 1C or 1H? Can somebody look those up so I know you're following? What's the molar mass of either C or H, or you can type in both if you know, and it'll be in grams. What's the molar mass of C or H? C is 12. Thank you, Brooks. So I've got 12.0 grams. This is for CH4, or C4H10. That's carbon, but I got to multiply by 4 because I got 4 of those, right? And the H, somebody else got the H. Pardon me. Good. And Tully has the H. A lot of you do. Thank you, everybody. Thank you, Tully, everybody. So I got 1.0. Remember, we're going to the tens place, so that's why I put 0.0. And I got 10 of those. Okay, add it up. Okay, 4 times 12. We can do that, right? 48 plus 10, 58.0 grams. But octone, look at this. I got 2 of them. So you know what? Can we multiply this by 2? So 58 by 2. Again, bear with me. You'll see why I'm doing this. I promise. I promise. 58 times 2 is 100 and what? Can somebody do that in their head? Grams. 58 times 2. I bet you don't need a calculator. What would it be? See if somebody's got it. 116. Thank you, Lisa. I'm going to put 0.0. Okay, so 116 grams. Okay, good. Next item. Plus, look at this. I need 13 O2s. 13 O2s. Well, O2 is what? Oxygen. Well, just one O is 16, right? So I need 16. No, but it's O2, isn't it? Thank you. A lot of you figured that out. Thanks, Marino and Stephanie as well. So for O2, 13 O2. Well, O2 is 2 times 16, so that'd be 32.0 grams times, that's into that. So then I got to go 2 times that. No, not 2 times. 13 times that. Okay, everybody see where I got 32? So 16, and then it's O2, so I got to double it. You okay with that? All right, now, I don't know if anybody can do that on a calculator. Let's think about it without a calculator. So 13 times 32. Well, we could do 3 times 32. That would be what? 96 plus 10 times 32. 96 plus 320. So it'd be 320, 420, 416. Can you beat me? Is that right? Is it 416? What do we get there? 13 moles times 32 grams per mole would be how much? Am I right? 416? Thank you for checking. So equals 416.0 grams. Now, I want to get the weight of the reactants. Can you add that up for me? So 416 plus 116, shoot, we can do that together. It'd be what? It'd be 500 and what? I bet you can do the rest of that in your head. So thanks everybody for getting the 416. Now I'm going to let you get 416 plus 116. So I want the weight of all the reactants together. So that equals how much? 500 and thank you, Yo and Brooks. 532.0 grams. Okay. Questions so far? Thanks everybody for bearing with me. Again, you're going to see why I'm doing this. Appreciate your faith in me. Okay, I'm going to erase this now, but I'm going to leave that 532 grams. Okay? All right? So you can leave the rest of yours on your notes, but I need some boardroom because I want to do the products now. Okay? Products. Okay, products. Let's go to the first one, H2O. So look up one O and two H's and add it up for me. What's the molar mass of water? I bet we can do that mentally. So two H's and one O. How much does 1 mole of water weigh? 1 mole of water weighs how many grams? Ooh, some of you are quick. I love it. Yeah, H's are 1, so I got 1 plus 1, and O's are 16. Thank you. A lot of you got it. Julius, Lisa, Tilly, that's great. So I got 16 grams. No, 16, sorry. Thank you. 18 grams, 18.0 grams times 10. I got 10 moles of water, right? So I got 10 times 18.0 grams. Well, that's easy, isn't it? That's just 180.0 grams. Okay, that's the waters. Let's now do the CO2s. Okay, for CO2, I bet you can do this mentally too. C is what? C is 12.0. O is 16.0. So you need two O's and a C. Can you add it up for me? So what would be the molar mass of CO2? It'd be grams. It'd be grams. Hey, good. Oh, some of you are quick. I love it. Thank you, Brooks, Lisa, Tilly. That's dynamite. It is indeed 44. 16 plus 16 is 32 plus 12 from the C is 44.0. You remember looking those up already for the problems we did, right? 44 grams per mole for CO2. Okay, now, thank you. Now we got to multiply that times 8. We got 8 of them. Here we go. 8 times 44.0 equals, and can you do that for me? What would it be? 8 moles times 44 grams would be how many? All right, dynamite, thank you. It is indeed 352 grams. Okay, now, last thing is to get the products, the mass of the products, we're going to add that. We're going to add 180 plus the 352 grams. And I'd like you to add that together and see what you get, okay? So 180 plus 352. 180 plus 352. Let's see what you get. Oh, you guys are quick. Look at that. Couple got it already. Thank you. Brooks, Lisa, Yo, and Aaron, dynamite. So it is indeed 532.0 grams. Huh? But wait a minute. That's the same as we got here. So the products were also 532.0 grams. That looks like an S. It's supposed to be a 5. Why? Why does that make sense? Yes, good. You're on your way there. Thank you, Brooks. What else can we say? Why does it make sense? Why should they be the same amount of mass? Look at this. I got different amounts of moles. Like here I got 18 moles. Here I got 15 moles. The number of moles is not the same. Isn't that weird? 2 plus 13, 15. So 10 and 8 is 18. That's not the same. But the mass is the same, isn't it? Yeah, they're balanced. But what are they? Okay, so let's I'm going to erase this, and we're going to use this little part. You've already done the math probably. So y okay. I got 4 markers. Okay. I'm going to weigh them mentally. Oh, okay, I weigh them. Okay, now I'm going to take off all the lids. Ready? I don't make a mess of myself doing it. And now it's like my reaction. Now I got 4 lids and 4 markers. And if I weigh the two together, of course they're going to weigh the same. Of course they're going to weigh the same, right? That's the same thing we did. All we did is rearrange atoms, right? We still got the same number of atoms because, like you guys said, it's balanced. Whoa, can I put these back together without me getting to be a big mess? Maybe. Okay. So, what you discovered is something called the law of conservation of mass. And it says, not surprisingly, the mass of the reactants equals the mass of the products. And of course, if I got, as all of you figured out, if it's a balanced equation. Doesn't that just make perfect sense? Like if I rearrange the atoms, think of me like taking them apart and then putting them back together. I still got the same amount of atoms. I still got the same amount of C's, H's, and O's. And now I'm just putting them in different positions. But they weigh the same on both sides, don't they? Isn't that beautiful? So you've just figured out, folks, the law of conservation of mass. Now, it's true under normal reactions. All you're going to study in chemistry at the John F. Kennedy School is normal reactions, unless you take the Leistung's course, in which case you will get, or Leistung's physics, in which case you'll get into some stuff by Albert Einstein, okay, and other scientists. And other scientists like Lisa Meitner and so on as well. So you will find out that sometimes mass can change to energy, and sometimes energy can change to mass. But under normal reactions, like you and I are going to study in grades 7, 8, 9, 10, this isn't going to happen. So this law is pretty much good almost all the time. Okay? All right. And see, your sister may be learning the exceptions to this rule, Lisa, if she has Chemie Leistung's course. And that's cool. I remember your sister very well. Is this like a physical change? No, Brooks. If I actually like lit this stuff on fire, the butane, and burnt it, I would get a chemical change because I get, Brooks, new chemicals. New chemicals. I can physically weigh both sides, so it's the same mass on both sides, but it's called a chemical change because the chemicals are different on the product side. Thank you. Good questions and comments. Any other questions or comments from anybody? This is obviously an important law, and I hope it makes sense to you if things are balanced. Yeah? Any other questions or comments? We did well. I'm glad you're participating so well. It makes my job easier sitting in my 1 square meter basement studio. Okay, good. All right, then let's do one more in our time remaining. Let's balance one more reaction. Fun. So ready? Let's see if we can balance this. Balance this. Hey. Do I have time? I got 3 minutes. I think we got just enough time. We already did that one. Okay, balance this. I've got BA, and I'm gonna leave off the phases, okay, to save time. So I got BA plus aluminum, and I got this big thing in parentheses called a nitrate, and I've got 3 of those. Forms BA NO3 2 plus Al. So essentially what's going on is we're pulling off these things, they're called nitrates. We're pulling them off the Al and we're putting them on the BA. But notice, my people, I've got 3 of them here and 2 of them here. That makes the balancing a little tricky. So we got to balance that by thinking about this like we would in math class. Okay, if I got 2 here and 3 here, what could I put in front of the big chemicals? We're going to worry about BA and Al later. I want to balance the nitrates first. Look at, I got 2 of them, 3 of them. So don't worry about the other 3 for now, just the outside. 3 of them, 2 of them. What could I put in front to balance that? Hint, we say in math class a common multiple. So how could I get the same number of nitrates. What could I put in front of here and in front of here? Yes, this is a little more complicated. I'm going to do it for you because we're about out of time. Okay, I need a common multiple. I need 6 of them. So I want to get 3. 3 times 2 is 6 nitrates. And then 2 times 3 is also 6 nitrates. And then the rest is easy. Well, I got 2 ALs. I got 2 ALs. I got 3 BAs. I got 3 BAs. I'll let you think about that at home. I'm going to give you an assignment, which is to balance some reactions, okay? And I'll look at it and I'll decide how much I'd like you to do. And yeah, and then we'll talk about those next week. Maybe I'll have it due Friday, okay? All right, you guys did a super job of participating today. Thank you so much. And yeah, we'll give you that assignment and see how that goes, and I'll grade the one from last week. Okay, stay healthy, everybody. Bye-bye.